This lab walkthrough session is being recorded and will be posted later this afternoon on the My TCC Blackboard page for this particular class. And today's schedule, we're going through the lab 10.8.2, which is 3 different topics: Cisco Discovery Protocol, which is a Cisco proprietary; Link Layer Discovery Protocol, which is open standard; and Network Time Protocol, which we use to synchronize all our log files across all their devices so we can track when an intruder comes in as he hops from device to device. All the log files will be in sync with each other. Okay, so I'm going to start with Packet Tracer. Okay, so we have mouse action, we have tape recording, we have audio, we have video. We're ready to go, and we'll start working on this 10.8.2 lab. And I'm going to use the first page of the lab to go ahead and, I always talk about using Cisco Discovery Protocol anyway. When you first start working on a lab, go ahead and plug all the devices together. And if it's a router, just do a no shutdown on the port. You don't have to give it an IP address. Give them host names, and then you can check and make sure your wiring is proper. So I'll go ahead and provision the devices. We're going to use the physical mode. I'll go and open up the wiring closet, and let's put a rack in there. Oops, that wasn't a rack. There's a rack. And let me provision to some of the devices here. I'm going to use the 4000 series router, since that's the one that's specified in here, the G001 and G00 type interfaces. Go ahead and put that power rack up to the top, and then I'll provision a couple of switches. And let's blow this up so it looks bigger. This as big as it gets. Oh, maybe a little bit too big. There we go. Now I'm going to correct the designation on the devices. I'll right-click on this and say, oops, click on it, and we'll click config, and we'll just change this name to R1. Then we'll go to the switch and configure it to be S1. And we'll configure the second switch to be switch 2. Okay, now let's go ahead and do the wiring. And he calls for, from R1 to S1, an Ethernet cable. So I'll go down and I'll pick a straight through Ethernet cable. And it goes from G001 of the router to F05 of switch 1. And then we're going to configure another cable. We're going to get another cable, and we're going to go from 1 to 1. There we go. So now we're all plugged together. There's no host PCs in this particular lab. So I'm going to do my little tricky stuff that I normally do, which is just go into each one and go to the CLI. And I'll go ahead and configure this router to have a host name. Oops, I misspelled something. Okay, I got stuck in the DOS building box. I'll do it backwards. We'll start with S2, go to the CLI, go to the enable mode, configure terminal, and hostname S2. Then I'll go to S1, go to the CLI, go to the privilege exec mode, go to configuration node, and give them a host name of S1. And let's see if our router has regained its census yet. How about control shift 6X? There we go. Okay, go to the privilege exec mode, go to the global configuration mode, and give them a host name of R1. There. I got to enable the G001 port so that the Cisco Discovery Protocol will pass through. It doesn't require Cisco Discovery Protocol as a data link layer 2 protocol. It doesn't require any IP addresses, but you do have to have the port not shut down, no shutdown, or it won't be able to communicate through that port. So I'll go to router 1 and I'll configure interface gig 0/0/1 and just do no shutdown. And that should be enough for us to make our little test. It'll take a minute for that to come up, but I'm going to go to the guy in the middle, which is S1. And let's ask S1 to show us his CDP neighbors. And he has shown us that S1, according to the viewpoint of S1, his port number 5 goes to router R1, to router R1's G001 port. That's the correct wiring. Switch 1 goes to switch 2, pin 1, port number 1 to port number 1. So our wiring looks like it's proper. This stuff here is because I changed its name from switch to switch 2, and it still hangs on to that for about 60 seconds. Okay, so we proved configure connectivity in our lab, and let's go through and actually step through the procedure they give us in the lab. So I'm on page 2 of the lab, part 1, step 1. We cabled the network up. Now let's configure basic settings for the router in step 2. So I'll go to the router prompt. Make this a little bigger so you guys can see a little easier. And we did assign a device name to the router. We made them R1. We haven't done the disable DNS lookup yet, so I should do that. I should do that. Oh dear. So go to the global configuration mode and say no IP domain lookup, which will prevent the little errors like I had from hanging the machine up. We're going to use class as the privileged exec encrypted password. So I'll say enable secret class. Then we'll assign Cisco as a console password. So I'll say line console 0 password Cisco. Let it be logged in. And then line BTY 0 through 4 password Cisco. Logins allowed. Then we're going to encrypt the plain text passwords. I'll go back to the pure global configuration mode, and that's service password encryption. That way the word Cisco as a console password and the VTY, the virtual terminal, telnet, or secure shell password won't be in plain text on the screen for anybody to see. Now we're going to create a banner, message of the day, whatever the message that your company tells you have to say on your devices. We used to say welcome, but we can't say that anymore. And shut down all, oh no, I'm sorry, I jumped in. Configure the interfaces as listed in the table above. Okay, so the only interface we have on R1, we have a loopback port and a gigabit port. So I'll say interface gigabit 0/0/1 and give them some IP address. 10.22.0.1. I already did the no shutdown, didn't I? So I can do it again. It won't hurt. It's still enabled. And now the other interface port we need to bring up is a loopback port. So interface, let's do this way. Configure terminal, interface, loopback 1. IP address of interface loopback 1 is 172.16.1.1. And you don't need to do a no shutdown command for loopback ports because they're born alive. I do show IP interface brief. We consider loopback is up and up. You can shut them down if you want to, but if you just create one, it's created in up and up state. That's kind of a weirdness. Everything else, physical ports, you have to. They're all in the administratively shut down. You have to bring them up manually. So the interface is looked at, configured. I can do a copy run start, save the configuration. And now let's do our switches. So the only thing I've done so far on the switch is I gave it a host name so we could test with CDP before we do the real stuff they tell us to do with CDP. So he has a device name S1. Let's disable DNS lookup. So I'll say no IP domain lookup. Oops, he doesn't like that. No IP domain lookup. There we go. Too ambiguous, too short. We're going to assign class enable secret class. And then we'll go line console 0 password Cisco login, and then line BTY 0 through 15 password Cisco login. We're supposed to encrypt the plain text passwords, so I'll go to the configuration mode and say service password encryption. That'll take care of that. And then a banner, message of the day. Shut down all unused interfaces. I'm going to skip that step just in the interest of time. That's where we're going to do, we would do an interface range command and shut down the ports we didn't want to use. So in switch 1, he's actually using ports 1 and 5. We'd shut down 2, 3, 4, and then 6 through 24, and so forth. Now let's save our configuration. Copy, run, start. And let's repeat this on switch 2. Oh, wait a minute. He did not tell us to put the VLAN address on there, did he? Oh my. I think he forgot to tell us to do that. I have to go back and do that on switch 1. Because otherwise, for network time protocol to work later on, he has to have an IP address. So I'll go to the configuration mode and do an interface VLAN 1. And according to the chart on the front page, switch 1 is supposed to have an IP address of 10.22.0.2. And it's supposed to have a default gateway address of his friendly neighborhood router 10.22.0.1. Now I'll do another copy instead. And then let's repeat these steps on switch 2. So we've already done the host name. Go to the configuration mode and say no IP domain lookup. Do enable secret class. Line console 0, password Cisco, login. And then line VTY 0 to 15, password Cisco, login. And then do service password encryption. And a banner, message of the day. And then I need to do the steps they left out, which is I'm going to go ahead and say interface VLAN 1. IP address for switch 2 is 10.22.0.3. And then IP default gateway is 10.22.0.1. Copy, run, start. We've saved that configuration now. So just as a sanity check here, let me go back to S1, see if I can ping my neighbors. They should have IP addresses now. Show IP interface brief. VLAN. Oh, I forgot to do no shutdown command. Oh my goodness. Let's go to configure T, interface VLAN 1, no shutdown. Oh, I forgot it on that one too. Config T, interface VLAN 1, no shutdown. Now, show IP interface brief, and it's 10.22.0.2. Can he ping 10.22.0.1? His router? Yeah, he can ping it, it's fine. Or kill the first one. Can he ping 10.22.0.3, his upstream neighbor? Oh, bad magic. Oh, okay, it was just ARP. Okay, good. So now if I check again, if I show, we know the connection is good because show CDP neighbor shows us that he sees S1 sees R1 on the left, he sees S2 on the right. So I'll go to switch 2 now and see if I can ping all the way through. Can I ping 10.22.0.1? Okay, it's fine. We can ping that, okay. All right, so we've configured the switches. And now I'm gonna go to page 3 of the lab and we're gonna use Cisco Discovery Protocol. So you notice he states that Cisco Discovery Protocol is turned on by default on all ports that are not administratively shut down that are running. CDP is running by default. You can say no CDP run on the whole box and turn it off on the whole box, but probably more likely you're gonna need a no CDP enable on maybe your port that goes off to an untrusted branch office or to an internet service provider. You don't want people coming from the outside world doing show me CDP neighbor and mapping out your network so they can try to attack it. Okay, so I'm going to type the command on R1. Let me go to R1. And we're going to show CDP entry S1. And we get a bunch of useful information about S1, including what model number it is, what its IP address is. He's running full duplex. So we can see the question is, what iOS version is S1 using? And it's listed here. He's using version 15.0 in this simulation, this sort of super duper on steroids macromedia flash simulation that Packet Tracer is. It's not actually booting and running the real code like you could with GNS or Cisco modeling labs or anything like that. Now on S1, use the command to see how many packets have been output. So show CDP traffic. Is this? Oh, CDP traffic is not implemented on Packet Tracer. Oh my. So we can't see that. Oh, here we go. Here's the step. Configure the SPI at the bottom of page 3. They finally tell us, yes, let's configure the VLAN addresses for 1 and 2 and configure the default address in order. So they did remember to do it. They just did it out of order. So this is what we see on R1. We see this command show CDP entry. I think that's why they told us to do it there, is they wanted to see its IP address. If I had actually followed his instructions and I had configured the IP address yet, it would not show that address yet. So when you're working in the field and you use Cisco Discovery Protocol and you find your neighbor device and there's the IP address, that's exactly the number you need to know, so you can tell that into that second device and start hopping through the network and documenting it. Now CDP is on by default on all devices, and now he's given us directions to disable CDP globally on all devices. So I'll start on R1. I'll say no CDP run. Maybe I gotta be in configuration mode. Okay, and I'll do that also on S1 and S2. So CDP is now disabled. Now LDP is not running, so we need to turn that on. So let's see, that's going to be LLDP run. Now I'm going to switch one. LLDP run. Go to R1. LLDP run. And it'll take a minute for those entries to show up. We're going to see here though that the when you show CDP stuff, let me go back to S1. I got it. When I did show CDP neighbor right here, it showed me my neighbors on the left and on the right. So let's see what happens now when I do show LLDP neighbor. Kind of looks the same, doesn't it? You can see at the top of the bottom, there's slightly different software. They're slightly different from each other in the sense that Portuguese is slightly different from Spanish, but they have many similarities. So I can still see my port number on my local device. I can see the port number on the remote device. Now we're supposed to type show LLDP entry. Maybe this is not, I bet you this is not implemented on Packet Tracer. Let's see what else here. No, it's not implemented. Okay, so we're going to go now to page 5, halfway down the page, and configure the network time protocol. So let me go to the router, which is going to be our NTP master. And what's the time? What's the clock? I set the clock earlier. It probably didn't remember it show because I So here's the time, March the 3rd, 1993. The older routers actually did have a battery backup in them. So the newer routers have a battery like a desktop PC does. So clock set, and the command is, we first of all, it's about 9:22. and it's April the 29th, 2021. Now let's do show clock. Okay, now it's set to that time. And if we go to the switch 1 and switch 2, they're probably going to be set to the wrong time. So show clock, they're set to 1993. So what we're going to do is we're going to turn, the purpose here, the big picture between network time protocol is, if you have a master clock somewhere in your network, it doesn't have to be exactly, you know, within 1 microsecond of the cesium clock that the government has, but just so long as all your devices and servers are set to the same clock, then the log files will be consistent with each other. And if you ever want to follow something happening, rippling through your network, you can check those log files, and the date and the time will be proper for this. So we have set the time on the router, and then we're going to configure the router. We checked on the switches, and the switches have the wrong time. The router has pretty much close time. So let's go to the configuration mode and say NTP, oops. And this is going to be the master clock. He says stratum level 4. Now let's go to our 2 client machines, which is our switch 1 and switch 2. Now it takes, on real machines and in Packet Tracer, it can take about 5 minutes for this to take place. This is kind of like watching paint dry or watching grass grow, which is pretty boring. So let's go and configure S1. And we'll go to configuration mode. And we'll say NTP server. What is the server he should look back to get his time? Well, 10.22.0.1, right? And I'll do it on S2 as well. NTP server 10.22.0.1. So if I do something like a show NTP status, he shows us the clock is synchronized right now. It's going to take 4 or 5 minutes. You think something goes wrong, but that's normal operation. It takes several minutes for this to take place. Show NTP associations. He's associated with that server. See that 10.22.0.1? He is associated with, that's the router. It was stratum 4. So you can see that he's already talking to them. But if we do show me the clock, it still says 1993. It's going to take a few seconds for that to take place. So we'll just hang this for a second and wait for that to take place. Now, while that's synchronizing, while we wait a moment for that to synchronize, we had our slight change in schedule because last week we didn't have the lab because I was going to the, all the computer science teachers were summoned to a district-wide advisory meeting. And so this lab 10.8.2 was pushed off to today. And I'm going to do, I was supposed to do password recovery and the TFTP function. And I'm going to do that. I'll post that in another recording that will show up in the recorded session. So I'll do that very, very, very soon now. We're still waiting here. I tested this earlier. It took 4 or 5 minutes. There we go. Yeah, it took about 3 minutes. So now he has the correct time. Now let's see if it worked with this one too. On this too. Let's go this one. Show me the clocking. It's okay. They're synchronized now. Everything's synchronized perfectly with the other device, with the R1 device, and now all the log files will be synchronized with each other. Okay, so there's a reflection question. I don't require a reflection question, but let's talk about it for a second. It says within the network, on which interfaces should you not use a discovery protocol such as Cisco discovery protocol or link a layer discovery protocol? And the reason is, if it's an interface that goes back to an untrusted network like an internet service provider, or maybe you have a connection with a business partner or a trading partner, and you don't want them coming in and looking at your network. If you did have CDP, which CDP is on by default on all interfaces, if you forget about it, and let's say you have a serial port that goes to a T1 line to an internet service provider, anybody on the internet can come in and show CDP neighbor and see your stuff. So you would disable that with no enable, CDP no enable on your individual interfaces. If you want to turn off with the entire box, just do no CDP run, and that would do it. Okay, so we've covered the lab 10.8.2. We looked at Cisco Discovery Protocol, showing connections between interfaces and host names and IP addresses and other useful information as network managers and technicians and engineers would use. We looked at Link Layer Discovery Protocol, which is the open source equivalent. Cisco Discovery Protocol is proprietary to Cisco, only is available on Cisco boxes. It's their proprietary code. Link Layer Discovery Protocol is an open source thing. It's available on many computers. Like if you run Windows and it tells you that this is your build a network neighborhood and Windows, and you can see your ISP connection, that's using Link Layer Discovery Protocol. And then we looked at Network Time Protocol, which for security purposes, we should synchronize all our devices together. So when we have to come back later in the future and synchronize their date and time for purposes of making sure all the log files are consistent with each other and they match each other, we would use that for that purpose. Okay, hang loose. I'm going to stop the recording.